Welcome to this chapter on ionic theory and electrolysis. But before proceeding any further with the discussion, let us see some properties of materials associated with this topic. We have two groups of substances, that is, body conductors and good conductors of electric current. Body conductors of electric current are known as body conductors because they can't pass electric current through them, and these are sometimes called insulators. Good conductors of electricity are those substances which can pass electric current through them. Examples of body conductors are such as rubber, wood, glass, plastic, and other materials with the same properties, which include nanometals. Examples of good conductors are metals and some solutions. Other materials allow a little amount of electric current to pass, and these are called poor conductors of electricity. It is like water. We are going to conduct the experiment, and the aim of this experiment is to investigate the materials that are good conductors of electricity. The apparatus and the materials that are going to be used in this experiment are connecting wires, ammeter, source of current, wire, glass rod, plastic pen, kerosene, dilute hydrochloric acid, sodium hydroxide solution, copper 2 sulfate solution, sucrose solution, sucrose crystals, copper 2 sulfate powder, pellets of sodium hydroxide, and a piece of iron nail. Before connecting the iron nail and the wire, the ammeter reading is 0. After connecting the iron nail and the wire, the ammeter is indicating the passage of electric current. Before connecting the glass rod, the ammeter reading is 0. After connecting the glass rod, the ammeter reading is still 0. Before connecting the plastic pen, the ammeter reading is 0. After connecting the plastic pen, the ammeter reading is still 0. Before connecting sodium hydroxide solid pellets, the ammeter reading is 0. After inserting the wires in solid sodium hydroxide, the ammeter reading is still 0. Before inserting the connecting wire in solid copper 2 sulfate, the ammeter reading is 0. After inserting the conducting wires in the solid copper 2 sulfate, the ammeter reading is still 0. Before inserting the conducting wires in solid sucrose crystals, the ammeter reading is 0. After inserting the conducting wires in the solid sucrose, the ammeter reading is still 0. Before inserting conducting wires into dilute hydrochloric acid, the ammeter reading is 0. After inserting the conducting wires into dilute hydrochloric acid, the ammeter reading indicates the passage of electric current. Before inserting the connecting wires into sodium hydroxide solution, the ammeter reading is 0. After inserting the connecting wires into sodium hydroxide solution, the ammeter is indicating the passage of electric current. Before inserting the conducting wires into copper 2 sulfate solution, the ammeter reading is 0. The ammeter indicates the passage of electric current. After inserting the conducting wires into copper 2 sulfate solution, before inserting the conducting wires into sucrose solution, the ammeter reading is 0. After inserting the conducting wires into sucrose solution, the ammeter reading is still 0. Before inserting the conducting wires into kerosene, the ammeter reading is 0. After inserting the conducting wires into kerosene, the ammeter reading is still 0. From our experiment, we have observed that all materials that have indicated the passage of electric current by the means of an ammeter are good conductors of electric current. Okay? Which include metals, such as mineral acids, such as hydrochloric acid, salts in molten state or solution form, such as copper 2 sulfate solution, and the bases or alkalis, such as sodium hydroxide solution.